Good morning, everyone. Like most of you know me, my name is Joe Prindible with Watson McDaniel. I'm also here today with Linda Hood. She's back in the corner there. We appreciate the opportunity to be here today. I did ask Jim, I had an opportunity last week, I asked Jim, I said, is there anything in particular you'd like us to cover today instead of doing our usual product review? And Jim mentioned you'd like me to talk a little bit about condensate recovery and cost savings. And what I really did was take our typical seminar, which is usually 2 to 3 hours, and really condense it down to about 18 slides. So you're going to get about a 2 to 3 hour seminar within 15 minutes here. But this is real important, not only from the cost saving standpoint, but it also puts you above the rest of the guys that are out there doing typical condensate recovery as part of a project or as a total project that incorporates heat exchangers or coils. So we're going to touch the highlights. I'm going to touch on the highlights of this. But first I always go through here. See if I can get this to work again. Maybe not. There we go. Okay. Those of you that are familiar with us, we're Watson McDaniel. We're located over in Pottstown, Pennsylvania. We've been there since '05, I believe it is. We're a manufacturer of steam and fluid products. And as some of the other manufacturers have mentioned, we are a domestic manufacturer. All our gray and ductile iron castings, now they come out of a foundry up in Hamburg, Pennsylvania. It used to be Donsko down in Wrightsville, but those guys sort of went towards the auto industry, so they forced us to make a change, but we're still a U.S. domestic manufacturer. Our castings are coming out of Pennsylvania at this time. Our stainless castings come out of Carpenter Tech over in Reading. All the manufacturing then, as far as the machining and the finished product, is done over in Pottstown. We have a document here that actually lists all our products that meet the requirement for the Buy American Act. You can see pretty much all our traps, the pumps, which we'll be talking about today, our regulators, and a lot of the other material items that we do manufacture meet these requirements. We can sign off on the ST forms that we see a lot in Pennsylvania when we look at the state projects. So we're going to talk about condensate recovery and some of the savings associated with that. When I talk about savings, it's not so much dollars that you're going to save on the condensate returning to the boiler to reuse it, but also the efficiency of your systems. So I'm going to talk a little bit about why we recover the condensate. That's a no-brainer. We save money. Talk about how we recover the condensate, a couple of the applications, and some of the forms that we use to calculate the savings. So again, we recover condensate for a number of reasons. Prevents excessive boiler blowdown, retains valuable heat energy, returning under pressure reduces corrosion in your system, saving heating expenses. More importantly, as we go down through the line again, it reduces our makeup water, our cost boiler feed chemicals, and the expense of preheating that boiler water in the boiler itself instead of bringing in fresh water and starting from a core temperature. Again, it just saves you money. We want to get that condensate back to the boiler and reuse it. A couple of different ways to get that condensate back. In a perfect world, it would be gravity return. Simple is better. We could use electric condensate pumps. There's still a lot of uses and needs for the electric pumps, but our preferred method is using a pressure motive pump. Simple piece of equipment, very similar to an electric pump. We're going to use a steam or air or any inert gases to use it as a motive, unlike an electric pump where we're using electricity. But again, all we're doing is working on a float level within the pump body to operate the pump. It's mechanically operated. You can get them in a variety of configurations. Let's see if I can do this here. And those of you that aren't familiar with the pump operation, let's see if I can get this to go here. Pretty simple operation. This is what we see inside here. Maybe it's not going to go. There it goes. This is all that's happening inside these pressure motor pumps. It's based on a float level. Once we get that float to the upper trip point, it's going to open up that steam inlet valve, steam or air, whatever motor we're using, it's going to pressurize that pump body and push that condensate back out. It's as simple as that. There's a cutaway of what's happening when that trips. We actually have two valves there. There's the steam motive inlet valve as well as our exhaust valve, so it's a dual setup on there. So when it's in the discharge mode, we've pressurized the body. In the fill mode, now we're exhausting. Very simple, very easy system to work on as well. The nice thing about these types of pumps now, especially the upright models, a lot of the manufacturers, what we call the mechanisms, are interchangeable. So there's a lot of flexibility for your customer in their system, where if they do have a failure, they've got a lot of options there to replace this. But that's pretty much the operation on the pressure motor pumps. And again, this is generally used in a 2 to 3 hour seminar. I just wanted to give you an overview of what's actually happening on the inside of these pumps. Now, when we talk about the benefits of using a pressure motor pump versus an electric pump, we go right down the line here. We can remove condensate in all load conditions, even in vacuum. You cannot do that with an electric pump. We have no mechanical sales to leak, no electrical power is required. They are suitable for hazardous locations. No cavitation problems, no emission problems in a closed loop. Talk a little bit about what we mean when we talk about a closed loop versus an open loop. Some more benefits, again, going right down the line. I'm not going to talk about each one of these. This is important though, from a cost of ownership with your customers. Again, they have that flexibility. They're not tied into, if there's one manufacturer that does not have the product on the shelf, there is that option of going to another manufacturer, dropping that into the pump bodies. And as far as capacities and operation-wise, very similar in operation. Again, this gives us a cutaway as far as what that mechanism looks like. It's a bolted flange connection, very easy to pull that complete assembly out. If you do have to work on the McDaniel assembly, I'm always up front with everybody, even with the customers. I've only ever worked on one of these things since I've been with Watson, just about 5 years now. As far as the parts that may need replacement over years will be the spring assembly. McDaniel's design is it's a dual spring, it's a compression spring, very easy to remove. They come in a kit with the springs. It's a cartridge design. You pull the cotter pins out, put the new cartridge in, you're back up and running. No other adjustments are required on there. It's a very easy system to operate and maintain. Some of the manufacturers now, you can play the marketing game. Some will say, hey, I've got a 3-year warranty. Well, we can do a 3-year warranty for no extra cost. You talk to some of you look at the different applications that are out there, you talk to the mechanicals that are doing these jobs. Some of those guys don't like that 3-year warranty because they don't have the money built into their projects to cover a 3-year warranty. But if you're dealing with the end user, they're going to want that 3-year warranty. We can offer that 3-year warranty for no additional charge as long as the pump is sized properly to the system. Other manufacturers, they tout that they'll have a 3-year warranty, but in order to meet the requirements of that warranty, this head assembly has to go back to the factory. They'll make a judgment on as far as what the reason of failure was, whether it's a mechanical failure in the field or something that happened down at the factory. Again, this is a repairable unit. Instead of having to send one back to the factory, wait several weeks to get it back, we can do it right in the field. A couple of the different applications when we talk about pressure motor pumps, and you hear the different manufacturers' terminologies. When we talk about it, we really have two different types of applications. There's an open system. That's where you have all your condensate multiple returns coming back to the pump. So we're going to have a vented receiver or an open system. This simply means that the system is open to atmosphere. We're going to have a vented receiver. That's our open system. Again, if we really want to get into sizing these things, it's very easy, but that's really another seminar in itself. But all this information as far as how to size these, how to size the receivers, how to size the vents. I don't know if you've had the chance, it's all in the current product catalog. Real nice catalog to use as a resource. But again, we talk about open system here, you can see we have multiple returns coming back in there. That way you're going to assure, regardless of what pressure of condensate is coming back, it's going to be coming into an atmospheric receiver. You're not going to create any kind of back pressure. That's what you want in your steam system as far as the condensate return side. Now we get into something that we see more and more today, especially in a lot of the state facilities, the universities, state prisons. A lot of facilities now are converting over from steam to hot water. And typically you see this a lot, whether it's a basic shell and tube heat exchanger. They say, hey, I'm going to switch over from steam to hot water. I'm just going to plug in a heat exchanger. I'm going to be golden. I'm going to be good to go. And a majority of the time what you're going to see is that condensate return coming off the bottom of the heat exchanger to an overhead return. A lot of drawbacks doing it like that. What we're going to look at is the complete system. You can't just look at it and say I need a heat exchanger doing 50 GPM, 15 PSI steam pressure, converting over my hot water flow, whatever it might be. The nice thing you can do with a pressure motor pump is we're going to take a look at this application, and this is a page right out of the book. You can actually take that information, run a calculation, what we call a stall calculation, and determine at what point or what flow that heat exchanger is going to pull vacuum or stall. This is critical because a lot of times you talk to the end users, universities or their dormitories, you're going to size these heat exchangers for maximum flow rate, maybe 100 GPM. That's great when you have a heavy load on the system, control valves wide open, you have all that pressure to push that condensate through. But what happens when you have the stragglers coming into the showers later in the morning where you're not running that 100 GPM, maybe you're at 25 GPM. So what happens is the control valve throttle's closed, you lose that differential pressure, that condensate backs up into your heat exchanger, you get the pinging and the banging, you get that temperature swings, you get people complaining, hey, what's going on with the water? This way, again, it's right out of the product catalog. You can help your customer out. You can determine whether or not it's going to be an install situation. And if it is, then instead of having just a trap coming off the heat exchanger, we plug in a pump. Now we're going to be able to drain that heat exchanger, air coil, whatever it might be on the process side under any condition. We can actually drain that heat exchanger in full vacuum. It's always nice if you get the chance to see an application where they have a compound gauge on there and how often these heat exchangers run in full vacuum. And if we don't have a pump on there, that condensate's not going to drain and they're going to have a very poor operating system. Jumping around here. Now I've had a chance to work with some of the people with IPS. Originally with McDaniel, we've partnered up with Alpha Laval. We've done very well with these units. Now we've branched out a little more because there's other applications where the customer said, I don't want a plate and frame heat exchanger, I want a shell and tube. So now we can go with the shell and tube, whether it's just a basic horizontal unit, or we can also do the vertical units now. I was out with Suzanne down at the, was it the York Hospital? York Memorial Hospital. They wanted a vertical unit. At that time, we didn't have that vertical unit available. Now we can offer all these different options, whether it's plate and frame, shell and tube. We can package these together. We can determine whether or not we need to put a pump on here. If it doesn't need a pump, we can just put a trap on there. But everything is sized for that application to address all the operating issues. To help your customer out as far as how do I calculate the savings, is it worth putting a pump in to get that condensate back? Today it's almost a no-brainer. Years ago there were some differences of opinion. It's not worth my time to install the piping to get that condensate back. With today's energy costs, again, it's a no-brainer. We have these forms, you can plug the numbers in as long as the customer has the information. And really what it entails is operating hours, water costs, chemical costs. You can do it off just a handwritten sheet copy. We have this in an Excel format. You plug those numbers in, and it'll give you an actual cost savings on an annual basis of what you'll save by getting that condensate back to the boiler and reusing it. This is the Watson-McDaniel form. This is one off the Department of Energy, right off the website. You can pull that information off the website. Again, all we're doing is plugging the information in as far as what your chemical, water costs, sewage costs are, operating hours, and it'll give you a cost savings based on an annual number. So, any questions? Again, these are the types of seminars if you have your customers, if they want to do a lunch and learn, whether it's just on condensate recovery, well, we can do these in the field. We also offer these types of seminars at the factory several times throughout the year, where it's more of a hands-on, you can actually see the equipment running. But again, getting into this information, helping your customers out this way, it really puts you above the competition where, you know, what makes it nice is you're local. We're 45 minutes up the road from you guys, so it makes a nice team effort. Again, it's a U.S. domestic product, which I really heavily promote anymore. And it is, I mean, you guys have all the other products, all our French fries to tie in with it. You have the pipes, the valves, the fittings to complete that package. So it's really a nice opportunity to get out there and get into some of these projects. Again, when you come around, if you have any questions, we'll be back here this afternoon. But, thank you.